The universe is estimated to be around 13.8 billion years old. This vast expanse of time began with the Big Bang, a moment when all matter, energy, space, and even time itself came into existence. Since then, the universe has been expanding, cooling, and forming the structures we now see: galaxies, stars, planets, and everything in between. When we look up at the night sky, we're not just seeing points of light, we're looking back in time. The light from the most distant galaxies has traveled for billions of years before finally reaching Earth. Some of the stars we see may no longer exist, their light still journeying across the cosmos long after they've faded. And every star you see, twinkling faintly above, is far larger and more powerful than you might imagine. Our own sun, bright and vital to life on Earth, is considered an average-sized star, not too big, not too small. In the grand scale of the universe, it's a fairly ordinary example. Yet even this ordinary star contains over 99% of the mass of our entire solar system and burns at temperatures of millions of degrees. It's a quiet reminder of just how immense and energetic the cosmos truly is. Space is not completely empty. It contains small amounts of gas, dust, and radiation. Even in the quietest corners, there are particles floating through the void. The largest known star is Scuti, a red supergiant that is more than 1,700 times the diameter of the Sun. If placed at the center of our solar system, it would engulf the orbits of Mercury, Venus, Earth, and Mars. Jupiter, the largest planet in our solar system, is so massive it could fit all the other planets inside it and still have room to spare. Saturn's rings may look solid from a distance, but they are made of billions of ice and rock particles, each one ranging in size from grains of sand to chunks as large as a house. Every time you feel the warmth of the sun on your skin, you're experiencing light that began its journey over 8 minutes ago. The sun, 93 million miles away, is so far that even light, traveling at nearly 186,000 miles per second, takes about 8 minutes and 20 seconds to reach us. That means the sunlight we see isn't the sun as it is now, but as it was minutes ago. We're always looking slightly into the past, and that's just the final leg of the journey. The light and energy we receive each day actually begins deep within the sun's core, where intense pressure and heat fuse hydrogen atoms into helium. This nuclear fusion releases immense amounts of energy that can take thousands, even millions of years to escape the sun's dense interior and rise to the surface. Once it breaks free, that light travels unimpeded through space, calm, silent, and steady, until it touches Earth, bringing life and warmth to our planet. It's a quiet miracle of nature. Every sunrise is not only the start of a new day, but the arrival of ancient light, born in the heart of a star, shaped by time and space, and finally arriving here, just in time to wake the world. Neutron stars are the remnants of massive stars that exploded in supernovae. They are incredibly dense, so dense that a single teaspoon of neutron star material would weigh around 6 billion tons. Black holes are even more extreme. Their gravity is so strong that not even light can escape, which is why they appear black. Time slows down near a black hole, a phenomenon predicted by Einstein's theory of general relativity. The Moon is slowly drifting away from Earth at a rate of about 1.5 inches per year. Over millions of years, this will eventually change the way eclipses work. Earth is the only known planet with liquid water on the surface, but scientists believe There may be underground oceans on moons like Europa and Enceladus. Far across the void, another great spiral galaxy is drifting toward us, Andromeda. It's the closest large galaxy to our own, and though it lies over 2.5 million light-years away, it's steadily getting closer, pulled by the gentle but persistent force of gravity. This isn't a sudden or violent event. The galaxies are moving toward each other at about 250,000 miles per hour. But space is vast, and the journey is slow. In roughly 4 billion years, the Milky Way and Andromeda will begin to merge, their stars passing through one another like ghosts. Despite the immensity of each galaxy, the spaces between stars are so wide that actual collisions will be rare. Instead, the two galaxies will swirl and stretch, drawn into new shapes by gravitational tides. Their spiral arms will twist and tangle, creating long, flowing streams of stars. Over hundreds of millions of years, this cosmic dance will continue, until eventually the galaxies settle into a new, unified shape, an elliptical galaxy, larger and rounder than either one alone. Our night sky will change dramatically. For future observers, if any remain, Andromeda will grow larger each night, eventually dominating the sky with a dazzling array of new stars. It will be a time of beauty and transformation. Even though this grand event is unimaginably far away, it reminds us that the universe is not still. Everything is in motion. Galaxies move. Stars are born and die, and over spans of time too great for a single lifetime to hold, even the heavens themselves evolve. Venus is the hottest planet in the solar system, even hotter than Mercury, despite being farther from the Sun. This is because its thick atmosphere traps heat in a runaway greenhouse effect. Mars, often called the red planet, gets its colour from iron oxide, rust, on its surface. A day on Mars is only slightly longer than a day on Earth, lasting 24 hours and 37 minutes. The Milky Way galaxy, which is home to our solar system, is estimated to contain over 100 billion stars. It's just one of an estimated 2 trillion galaxies in the observable universe. The Milky Way is on a slow collision course with the neighbouring Andromeda galaxy. They are expected to merge in about 4 billion years. The Milky Way is our home in the universe, a sprawling galaxy of stars, gas, dust and dark matter, gracefully spiraling through the cosmos. It's a barred spiral galaxy with long, graceful arms that wind outward like ribbons from a central core. When you look up at the night sky and see a hazy band stretching across it, you're seeing just a tiny slice of this immense structure from the inside. It's estimated that the Milky Way contains over 100 billion stars, and perhaps even more planets. Our Sun is just one of those stars, tucked away in a relatively quiet neighbourhood known as the Orion Arm. From our vantage point, we can't see the galaxy's full shape directly, but by studying distant stars and the motion of gas, astronomers have pieced together a remarkable picture of its form. The Milky Way is roughly 100,000 light-years across. That means even travelling at the speed of light, 186,000 miles per second, it would take 100,000 years to go from one end to the other. And yet, our galaxy is just one among billions, floating silently in a sea of cosmic structure that stretches beyond imagination. At its centre lies a supermassive black hole called Sagittarius A star, millions of times more massive than our Sun. It anchors the galaxy and shapes the motion of stars around it. Though we cannot see it, its presence is unmistakable. The Milky Way is not static. It's constantly changing, moving, evolving. Over time, it draws in smaller galaxies, grows new stars, and slowly spins in a cosmic rhythm that's been playing out for billions of years. It's easy to forget in the quiet of our own lives that we are part of something so immense. But every atom in your body came from a star in this galaxy, making each of us a small luminous thread in the tapestry of the Milky Way. Light takes about 8 minutes and 20 seconds to travel from the Sun to Earth. That means when you see sunlight, you're actually seeing the Sun as it was more than 8 minutes ago. Mercury has no atmosphere to speak of, so temperatures swing wildly from over 800 degrees Fahrenheit during the day to negative 290 degrees at night. The International Space Station travels around Earth at roughly 17,500 miles per hour, orbiting the planet every 90 minutes. That means astronauts on board see 16 sunrises and sunsets each day. Space is completely silent. Without air to carry sound waves, there's no way for sound to travel. Earth's atmosphere fades gradually into space, but the boundary commonly used to define the edge of space is called the Kármán line, located 62 miles above sea level. The Sun makes up more than 99.8% of the total mass of the solar system. It's powered by nuclear fusion, converting hydrogen into helium and releasing massive amounts of energy in the process. A year on Neptune, the farthest planet from the Sun, lasts about 165 Earth years. Pluto, though no longer classified as a major planet, has 5 moons. Its largest, Charon, is so big that the two bodies actually orbit each other like a double planet. Mars, often called the Red Planet, glows with a warm copper hue in the night sky. Its color comes from iron-rich dust that coats its surface, dust that has oxidized or rusted over time. This thin layer of iron oxide gives Mars its signature red appearance, a distant reminder of the minerals and chemistry that once shaped its ancient landscape. Though smaller than Earth, Mars has captivated our imagination for centuries. It has mountains, valleys, deserts, and polar ice caps that grow and shrink with the changing seasons. The planet's air is thin, composed mostly of carbon dioxide, and offers little protection from the harsh radiation of space. Still, there are signs that liquid water may once have flowed here. Dry riverbeds, ancient lake beds, and the layered sediments of old deltas suggest that Mars may have once been a wetter, more hospitable world. A day on Mars is strikingly familiar. It lasts just over 24 hours, only 37 minutes longer than a day on Earth. Its seasons are longer too, because it takes nearly twice as long to orbit the Sun. Dust storms can grow so large they cover the entire planet, cloaking the red surface in a swirling, hazy veil for weeks at a time. And though it's a cold and barren world now, Mars continues to be one of the most likely places in our solar system where life might once have existed, or where it could one day exist again. It's a quiet planet, full of echoes from the past and possibilities for the future. Halley's Comet is visible from Earth approximately once every 76 years. The next expected appearance is in the year 2061. The footprints left by astronauts on the Moon are still there today. With no wind or weather to disturb them, they may last for millions of years. Stars don't actually twinkle. The twinkling effect is caused by Earth's atmosphere, distorting the light as it travels through it. Our galaxy smells like raspberries and rum. At least, that's what scientists detected in the dust cloud near the center of the Milky Way, where the chemical ethyl formate is found. Venus is often called Earth's sister planet. It's similar in size, mass and composition, but the resemblance ends there. Beneath its soft yellow glow lies a world of extremes, hidden under thick, toxic clouds. Despite being farther from the Sun than Mercury, Venus is the hottest planet in the solar system. Its dense atmosphere is made mostly of carbon dioxide, and it's over 90 times thicker than Earth's. That atmosphere traps heat with relentless efficiency, creating a runaway greenhouse effect. Temperatures on the surface can reach nearly 900 degrees Fahrenheit, hot enough to melt lead. The clouds of Venus are filled with sulfuric acid, and the pressure on the surface is so intense it would crush a human lander in minutes. Yet the planet turns slowly, taking 243 Earth days to complete one rotation. Strangely, its day is longer than its year. And to make it even more unusual, Venus spins in the opposite direction of most other planets, including Earth. On Venus, the Sun would appear to rise in the west and set in the east. No life as we know it could survive there. But still, Venus fascinates scientists. Its atmosphere may hold clues about Earth's own climate future. And high above the surface, where conditions are less extreme, there are layers in the clouds where temperatures and pressures are surprisingly Earth-like. Venus is a haunting vision of what a world like ours might become under different circumstances. Beautiful, bright, and fiercely unforgiving. A day on Venus is longer than its year. It takes about 243 Earth days to rotate once on its axis, but only 225 Earth days to orbit the Sun. Mars has the tallest volcano in the solar system. Olympus Mons stands nearly 13.6 miles high, almost 3 times the height of Mount Everest. If you could fold a piece of paper in half 42 times, it would reach the moon. It sounds impossible, but it's a real example of exponential growth. The observable universe is estimated to be about 93 billion light-years in diameter. That means we can see objects that are 46.5 billion light-years away in every direction. Some scientists believe that space may be infinite, while others think it could be curved and loop back on itself. Either way, the true size of the universe remains unknown. In space, temperatures can drop to negative 454 degrees Fahrenheit, just above absolute zero, the coldest temperature possible. There are more stars in the universe than grains of sand on all the Earth's beaches combined, and yet, planets may outnumber stars by an even larger margin. A single galaxy cluster can contain thousands of galaxies, all bound together by gravity. The largest known structure in the universe is the Hercules Corona Borealis Great Wall, a massive group of galaxies stretching more than 10 billion light-years across. The James Webb Space Telescope can see light that's over 13 billion years old, allowing us to glimpse galaxies forming shortly after the Big Bang. Astronauts in space grow up to 2 inches taller due to the lack of gravity compressing their spines. The Hubble Space Telescope has taken over 1 million observations since it launched in 1990. Some of its images have changed the way we understand the universe. A day on Jupiter lasts only 10 hours. It's the fastest spinning planet in the solar system. The Kuiper Belt beyond Neptune is a region filled with icy objects and dwarf planets, including Pluto. Oort cloud, a hypothetical shell of icy bodies, surrounds the solar system and may be the source of long-period comets. Tidal forces from the moon cause Earth's oceans to rise and fall in a rhythmic pattern known as tides. Without the moon, Earth's axial tilt could vary wildly, leading to extreme climate changes. Earth's magnetic field protects us from harmful solar radiation. Without it, life might not exist here at all. Solar flares are sudden bursts of radiation from the sun. They can disrupt communications and even damage satellites in orbit. The northern and southern lights, or auroras, are caused by charged particles from the sun interacting with Earth's magnetic field. Some exoplanets, planets outside our solar system, are locked in eternal day on one side and eternal night on the other. Others rain molten glass or have winds that reach thousands of miles per hour. Light bends around massive objects like galaxies in a phenomenon called gravitational lensing. This allows us to see distant objects magnified, like looking through a cosmic telescope. Cosmic microwave background radiation is the leftover heat from the Big Bang. It's the oldest light we can detect. If you look at an old analog TV tuned to a dead channel, a tiny percentage of the static you see comes from this ancient radiation. The universe is expanding, and not just that, it's accelerating. Galaxies are moving away from each other faster and faster, driven by a mysterious force called dark energy. We still don't know what dark energy is, or what dark matter is either, which makes up about 27% of the universe. Despite what we often imagine, space is not a perfect vacuum. It's not completely empty. Even in the most remote and silent stretches of the cosmos, there are tiny traces of matter, thin clouds of gas, drifting dust particles, and the faint hum of cosmic radiation left over from the birth of the universe. These fragments are sparse, so thin that they wouldn't be noticeable to the human eye, but they are there, quietly floating through the dark. These small traces tell us that the universe is never truly still. Even in its quietest corners, space carries whispers of energy and matter moving gently through the void. And within this immense backdrop, we find objects of unimaginable size and scale. One of the largest stars ever discovered is a red supergiant known as Scuti. It's so massive that if we could place it where our Sun is now, its surface would stretch far beyond Mercury, Venus, Earth, and even Mars, swallowing the first 4 planets of our solar system entirely. Though it lies nearly 9,500 light-years away, Scuti reminds us how vast the cosmos can be. Compared to this stellar giant, our Sun would appear as little more than a glowing dot. These immense stars live fast and die young, burning through their fuel quickly before collapsing in spectacular explosions known as supernovae, brief moments of brilliance in the slow rhythm of the universe. Jupiter, the largest planet in our solar system, is a true giant. It's so massive that it could swallow all the other planets combined and still have room to spare. Its swirling clouds, painted with bands of orange, brown, and white, are made up mostly of hydrogen and helium. Beneath those clouds, storms rage for centuries. The most famous of them, the Great Red Spot, is a colossal cyclone wider than the entire Earth, spinning quietly through the planet's upper atmosphere. Despite its size, Jupiter spins faster than any other planet. A single day there lasts just under 10 Earth hours. Its immense gravity pulls in comets and asteroids, acting like a cosmic shield for the inner planets, including Earth. Without Jupiter, the history of our planet, and perhaps of life itself, might look very different. And although Jupiter has no solid surface, it's surrounded by a retinue of more than 90 moons, each with its own story. Some are icy, some volcanic, and a few may even hide subsurface oceans beneath their frozen shells. Quiet worlds orbiting a silent giant, drifting endlessly through the dark. Saturn is often called the jewel of the solar system, and for good reason. Encircling the planet are its magnificent rings, broad, bright and delicate looking from afar. But up close, those rings are made of countless individual pieces of ice and rock, ranging in size from tiny grains of dust to massive chunks the size of houses. They shimmer and scatter sunlight, giving Saturn its ethereal glow. Though they look solid, the rings are incredibly thin, only about 30 feet thick in most places, despite stretching out over 170,000 miles from the planet. Scientists believe they may be remnants of a shattered moon or comet, torn apart by Saturn's immense gravity long ago. Saturn itself is a gas giant, made mostly of hydrogen and helium. Like Jupiter, it has no solid surface and spins rapidly, giving it a slightly flattened shape at the poles. A day on Saturn lasts just over 10 hours. Winds in its upper atmosphere can reach over 1,100 miles per hour, making it one of the windiest places in the solar system. And orbiting this giant are more than 140 moons, including Titan, a world with rivers, lakes, and seas not of water, but of liquid methane. A distant, frozen landscape with clouds, weather, and perhaps the ingredients for life, hidden beneath an orange, hazy sky. When a massive star reaches the end of its life, it doesn't fade away quietly. Instead, it collapses in on itself and explodes in a supernova, a brilliant burst of light and energy that briefly outshines entire galaxies. What remains can be one of the densest objects in the universe, a neutron star. Neutron stars are astonishing in their density. They cram more mass than the Sun into a sphere no wider than a city. To put it into perspective, a single teaspoon of neutron star material would weigh about 6 billion tons. Their gravity is immense, and their magnetic fields are among the most powerful known. Some spin rapidly, emitting beams of radiation like cosmic lighthouses. These are known as pulsars, ticking steadily in the dark like the universe's own heartbeat. But if the original star was even larger, the collapse doesn't stop with a neutron star. It continues until all known physics breaks down and a black hole is formed. Black holes are regions of space where gravity is so strong, not even light can escape. They don't pull things in like a vacuum cleaner, but rather curve space itself so steeply that nothing crossing the boundary, called the event horizon, can return. Time slows down near a black hole. In theory, to an outside observer, it nearly stops. At the very center lies a point called the singularity, where matter is crushed into infinite density. It's a place beyond our understanding, where the known laws of physics no longer apply. Black holes may seem like cosmic endings, but they are also places of incredible mystery, and perhaps one day deeper understanding. The moon has been our silent companion for over 4 billion years, quietly orbiting Earth and lighting up the night sky. But what many don't realize is that the moon is gradually drifting away from us. Very slowly, just about 1.5 inches per year, it's moving farther into space. This gentle retreat is caused by the complex dance between the Earth and the moon, tied together by gravity and the pull of the tides. The moon's gravity tugs at our oceans, creating the rise and fall of the tides we see every day. But in return, those tidal movements exert a subtle force on the moon, pushing it ever so slightly farther out into its orbit. Over millions of years, this tiny shift adds up. Hundreds of millions of years from now, eclipses will look different. The moon will appear smaller in the sky, and total solar eclipses, where the moon perfectly covers the sun, will eventually become a thing of the past. And yet, in this slow separation, there's a kind of poetic stillness. The same force that once brought the moon close to us is now giving it the freedom to drift. A reminder that even in the heavens, relationships change, slowly, gently, and always in motion. Earth is the only known planet where liquid water flows freely on the surface. It fills our oceans, rivers, and lakes, shaping the landscape and nourishing all life. Water covers more than 70% of our planet, and it's essential to everything we know and are. Its presence in liquid form, stable over billions of years, is one of the main reasons life has been able to thrive here. But Earth may not be the only place with oceans. Far beyond the warmth of the sun, in the icy reaches of our solar system, there are moons that may hold vast seas beneath their frozen surfaces. Europa, one of Jupiter's largest moons, is covered in a shell of ice. But beneath that shell, scientists believe there's a global ocean, deeper than any on Earth. Kept warm not by sunlight, but by the tidal forces from Jupiter's immense gravity, this ocean may be one of the most promising places to search for alien life. Enceladus, a smaller moon orbiting Saturn, also shows signs of hidden water. Geysers of ice and vapor burst from cracks in its surface, hinting at a subsurface ocean below. These distant, icy worlds are dark and cold on the outside, but beneath the surface there may be warmth, movement, and perhaps even life in forms we've never imagined. In the quiet of deep space, where nothing seems to stir, these hidden oceans whisper of the possibility that we are not alone. Time itself may have begun with the Big Bang. Before that, the concept of before might not even apply. Wormholes, if they exist, could theoretically connect distant parts of space and time, like shortcuts through the fabric of reality. Some scientists speculate that our universe might be one of many in a multiverse. In this idea, countless other universes with different laws of physics could exist beyond our own. The silence of space, the sheer scale of time, and the wonder of cosmic evolution all remind us how small and how special we really are. As your mind drifts farther into sleep, remember that the universe is still unfolding. With every telescope, probe, and question, we learn just a little more. And somewhere, far beyond our sky, the stars keep shining quietly, waiting to be seen.